Hello and welcome back. Today I would like to solve a problem. I would like to talk about some low-level details of storage, distributed storage platform. I'm working for Storj Labs and I think there are a lot of interesting stuff there to share. But the problem is that I have never introduced storage properly in this channel. So without an introduction, it would be very strange to start about low-level details, even if that would be what I prefer. So, but instead of having a generic introduction, I prefer to compare it. And maybe the comparison can be an introduction because it can show some differences compared to Hadoop HDFS/Ozone. And I worked on both. Actually, I think I still have more commits in Ozone and HDFS. So let me share what I think about those. But first of all, we need to explain these two lines. First, what is Hadoop HDFS/Ozone? Why are there are so many slashes? So Hadoop is a project under Apache Software Foundation. I think it's more than 10 years, maybe 15, I don't know exactly. And it has multiple sub-projects. It had the MapReduce, but it's not very active. So I think the most active sub-projects currently, the storage part and the execution part, because Hadoop, the main idea is Hadoop just to execute some big data calculation on top of, with the help of community hardware, so kind of any kind of hardware. So, how can I do another arrow? Maybe in this, okay. So this is how Hadoop looks like, because MapReduce, it's old, I think. Flink or other streaming services just replaced it. But for a few years, we had a new version of the HDFS, which is another storage systems, and it was Ozone. But eventually, it was moved to a separated top-level Apache project. So this is why it's Hadoop/HDFS/Ozone, because Ozone and HDFS kind of similar, but Ozone is some kind of rewrite of the HDFS based on the experiences learned over the years. So let's go back to the second line. The major differences. Yeah, we need to have some number in the title just to make it popular, right? Now, so the question is that why do we talk about differences at all? They seems to be very, very different, right? If I check this storage stuff, this is some cloud storage, and it's the data is stored everywhere in a distributed manner, while the Apache Ozone and Apache HDFS. But let's talk about the Ozone. It's more like about some storage for distributed for the big data workload. So you should think about like a Kubernetes cluster or a good old Hadoop cluster where you would like to store a lot of data, your own, in your data center, in your cluster. So even if those use cases are kind of different, but if we check how the architecture, surprisingly, they are very similar. So actually, both of these storage systems, let's say Ozone and storage, works in a very similar, uses a very similar pattern. So we have a file what we would like to store, which is 3 size. Let's say this is the size of the file, and we are just splitting to smaller blocks. And this is not the only way to store data, but usually it's a very common pattern to store the file content in small blocks or segments. Storage calls them segment, HDFS calls them blocks. And after that, we need to replicate this one to different servers, which can be called storage node. In for storage and data node for Ozone and HDFS. And usually we need multiple replicas just to make sure we have it, and we need to store all of these. So this is what this is how Ozone and storage look like. So kind of similar. So maybe we can talk about the differences. And if we check the architecture itself, usually we find a metadata server for this part, just to maintain what kind of files are owned by a specific user. So let's say I have some. This is called satellite for storage and name node for HDFS. And there are these nodes which store the data, and somehow they are connected. That's the architecture in both of the systems. One difference is that in storage, by default, or everybody can join to the network, similar to the other distributed projects, and there are 20,000 of nodes by default. And obviously for a big data system, you should start your own nodes. It depends on the size of your cluster. So first difference. Let's talk about this one. So we discussed that we need to store this kind of association. And actually the file structure, usually it's some kind of object store, so we have buckets, and inside the buckets we have some kind of files. So how can we do it? So storage uses a very simple approach. There is a database here, and everything is stored in the database. And the database can be scaled up and down. Let's say this is a cockroach DB, which is the case of in case of storage, and this one also can be scaled up and down, the metadata server. HDFS and Ozone uses a different approach and tries to solve this problem by our own. So it means that inside here we have some kind of small database. Oh, I couldn't. So let's say we have a very small database here which stores the data, and the replication should be solved by own. Which means that, first of all, it's way more complex because you need to implement something. For Ozone example, in case of Ozone, for example, this is a raft consensus between the nodes. So let's say I have 3-1 to have the quorum, and the data is in RocksDB. So it's kind of re-implementation of a database, which means that it's very hard, even if the raft consensus is announced as the something which can be understood easily. And on the other hand, it can be customized just for the specific use case. So there are pros and cons. And just as interesting stuff, there is a fork of Hadoop HDFS, and this is Hops FS, which is a fork of, I think, the old version of HDFS, maybe Hadoop 2. I don't really follow this one. And it says that the metadata is stored in the MySQL. And another comment that there are reasons to store the metadata internally, especially in memory everything, because that was the original goal with Hadoop, to store everything in memory to make it very, very fast. And if you are interested about the original motivation, you can check the Architecture of Open Source Applications, which is a free book. And I think there are 2 volumes. And in the first volume, there is this explanation about the motivation, the architecture, and some motivation. Why is it designed in this way? So that's a big difference in the metadata level. And actually in Ozone there are 2 kind of, so even these 2 maps this one and this one managed by two microservices, but it's not a very big difference, I think. So in Ozone there are a storage container manager and an Ozone manager, but this is kind of architecture, microservice architecture, and even for storage, it's not one process to do all of this stuff, but it's kind of different split. Okay, second difference. Let's talk about the storage nodes or data nodes. So they store all of these single pieces, but somebody should know what is stored where, right? We need to recover in case of problems, so we should know what's there. So in case of Hadoop and HDFS and Ozone, these nodes reporting back. What do they have? This is in HDFS, this is the block report, which is a very huge list of every single block, especially if you have small files. Originally, Hadoop is designed to store big files, but if you have small files because you stream, it's a lot. So there are some optimization like incremental block reports and everything, but that's how does it work. In case of storage, there is no such report. There is this metadata server, so this server supposed to know everything. Where are the blocks? But this storage node doesn't really report back. For example, there is if this guy, the metadata server, would like to ask some storage node to delete out of the pieces, it just sends a Bloom filter, which is a very tricky small information, which includes some kind of hash that what are the blocks which really should be kept, and the way how does it constructed that it's safe to delete, which doesn't match in the Bloom filter. So because there is, it's not clear what is there and what is not yet deleted, so it should send some generic order to delete all of the old stuff. This is what I think you have. On the other hand, Hadoop or HDFS and Ozone, these are reporting back, which is a scalability issue as well. So this is one reason why HDFS couldn't scale beyond, let's say, 500 million of files. It can scale, but it became a bigger and bigger challenge. So because all of the blocks are reported back. So actually, Ozone solved this problem, which is something in middle. Still, the storage nodes are reporting back the availability of the blocks, but they are not reporting about blocks, because the problem is here that I need a separated metadata for this one, for this one, for this one. But what Ozone does is that instead of having small entries for blocks, it has a bigger entry, which is called container. So which means that this is somewhere in the first slot in the container 1. This is in the second slot in the container 2, and this is in the first slot in the container 2. And the containers are huge, like 5 gig or more. So, and it's enough to replicate the containers. And here it reports back only the containers. I still have the container 1. This is very effective. There is one complexity here, that here I have the container address, and after that I'm moving to this one, and somewhere here we need some more metadata. So actually we just decentralize some of the metadata, because here I need to know that, okay, the container 1/1, in the first slot, how big is the first slot of the container 1? In the normal approach, or the traditional approach, this is a metadata somewhere in the metadata server. Here, this one, the metadata inside the container, is just stored somewhere in the storage node. But let's quickly move to the third difference. So, which is about security. So somehow I'm here and I would like to download data. And obviously first I'm connecting to the metadata server. I'm authorizing and I'm authenticating myself, and based on the authorization, I got something kind of token which can be used to download the data from these. And this is true for both Ozone HDFS and even for storage. The token is somewhat similar, the authentication is somewhat similar. HDFS Ozone prefers Kerberos, but even the format of the authentication, it's for storage, it's some kind of signature and certificate based, and Ozone uses a very similar approach. But the big difference is that Ozone and HDFS thinks that all of the storage nodes are good guys. So this is the Byzantine versus non-Byzantine failure, and this is the similar difference between a blockchain where all of the participants assume to be bad actors sometimes. So every failure should be surveyed, even if something behaves intentionally badly. But Ozone HDFS is not prepared for this. But because in storage, all of these storage nodes are operated by third-party actors like me or anybody. You can start a storage node. We need guarantees that the storage node couldn't lie about something. So which requires different approaches. So even if the storage node operator tries to behave badly, then everything should work. And one interesting point is that I have seen earlier a paper which argued that even for big data clusters, which are controlled by the same organization, and we can trust in all of the components, should be handled like an untrustful environment, because the disks, we couldn't trust in the disks. And it's possible that we have some disk here, and somehow it returns different kind of bytes. So this paper argued that everything should be double checked. I think it's still a difference that eventually the storage node could lie, or it tries to use all of the small doors and just try to work around to get more money. So I think it's still a big difference. But interesting that even for the big data environment in controlled cluster, it was an idea just to handle all of the storage nodes are something which can be trusted, because who knows what the hardware will answer in case of a failure. So I think these were the differences. There are more differences, but also similarities, as we have seen. And I think now we are ready to dig deeper and check a few interesting technical details in the universe of storage.